I see.
Hello, Haripriya. Wait. Let me quickly start this one. This one we have done, no? In the last class we have done that.
Yes, sir, you completed it.
Now I'll be telling you. To wait. Series and parallel connection. Series and parallel cases in heat and mass, hence in conduction. Series and parallel cases in conduction. Question भी है. Combination of conductors in series. See, what's the concept? There are, suppose, 3 conductors which are joined end to end. This has a length L1, this has a length L2, this has a length L3. The conductivity of this one is K1, this is K2, this is K3. Let's say the temperature here is T1, on this surface is T2, here T3 and here T4. Now, see, the concept is, since we know rate of heat transfer is compared with the current, and if the area of cross section is A, suppose we say it is of A1, the cross section area here is A2, here is A3, then the resistance is given by L by Ka, and the voltage difference delta V is given by temperature difference. This is the concept we know. So what we will be doing here, because we know in series I remains same and current electricity we know from lower classes, but V changes, delta V changes, voltage changes, but current is same. So what will be there? dq by dt will be same for all. Means I can write dq by dt is equal to T1 minus T2 by L1, means delta V by R1. What I am doing now, I will be equal to delta V1 I'm comparing with the current. V1 by R1 equal to delta V2 by R2 equal to delta V3 by R3, like that. So what equation I can write? T1 minus T2 by L1 by K1A1, T2 minus T3 by L2 by K2A2, T3 minus T4 by L3 by K3 A3. See, I know you are very comfortable in, you must be very comfortable in current electricity, is series and parallel cases. So that's why I'm comparing that with this one, this with that one. So if you know this one properly, I current is equal to voltage by resistance, then easily you will be able to frame this kind of equation to solve the unknown quantities whatever they've asked. And also we can convert, since we are assuming this, means we are thinking this as resistances, the resistances R1, R2 and R3, we can make a equivalent resistance for this, R equivalent, which will be R1 plus R2 plus R3. And what will be the voltage difference? T1 minus T4. So I can also write I, which is dq by dt, is equal to voltage difference T1 minus T4 divided by R1 plus R2 plus R3. That is L1 by K1 A1, L2 by K2 A2 plus L3 by K3 A3, when it is compared with current delta V by R1 plus R2 plus R3. You understood now what I'm trying to show? Yes, I'm trying to actually solve this problem using current electricity concept. So actually when they give you in the books, they will give you only these two box formulas, but comparing them with the current electricity is your take. Similarly, this is for series. Now if I give you the example for parallel, parallel combination means one is this, the other is this. Let's say it has a length L1, cross section area A1, and since they are in parallel, their temperature difference has to be same. This is T1. Here should be temperature T2. Let's say the cross section area here is A2. Length is L2. How we will know it is in parallel? In parallel, the voltage difference should be same. Meaning the temperature difference between the two ends should be same. That's the thing. Wait. Since in parallel, if we show by using current electricity, it can be shown like this. This is R1, this is R2. Here is temperature T1, voltage V1. Here is voltage V2. So the voltage difference V1 minus V2 will remain same. So, and how we do it? In the parallel, the total current I is divided like this, I1 and I2. So I is equal to I1 plus I2 is the equation that we can write, which is dq by dt is equal to dq1 by dt plus dq2 by dt. Okay, and dq by dt is v1 minus v2. Sorry, I actually get confused since I comparing. dq by dt is t1 minus t2 divided by L1 by K1 A1. No. We do not know, na? R equivalent, you write. We do not know the equivalent length and all, but write R equivalent like that. So it will be T1 minus T2 divided by L1 by K1 A1 plus T1 minus T2 by L2 by K2 A2. Like that you can do. Where R equivalent we do not know. If they suppose they give you in the question this setup is replaced by some length L and area A and K equal conductivity as K, then R equivalent will be L by K. Accordingly, you solve the question for the unknown quantity. Okay, I think you have understood. Now let me give you question. Try solving this one. What happened? You're not able to solve? Priya, Kanishka, you're able to solve it or not? What happened? Took so much time. You are not able to solve this. You're finding it tough, Priya?
Sir, I'm getting something in decimals. Wait, sir.
You're not getting right answer. Means the answer they have given is 40.
1 minute.
Actually, see what this configuration is. This 1 and 2 are in parallel, and this third is in series with the 1 and 2. Means how it is, this configuration you can draw like this. Like this. This is R1, this is R2, and say it is R3. Since this area seed is half, so it should be A by 2. This should be A by 2, and this should be A. Length is same, na? Length is same. This is of length L, this is of length L. Now see, if the resistance, if I try to write, R1 will be equal to L by K, K by 2. R2 will be equal to again L by K2, K by 2. R3 will be L by K3 into A. Now here the temperature is 100, here is theta, and here is 0. So the equation that I will write is theta minus 0 by R3 will be equal to 100 minus theta upon R1 plus 100 minus theta upon R2. That's I is equal to I1 plus I2 that I'm writing. Okay, Kanishka, this is I, this is I1, and this is I2. Now put the values. Theta divided by R3 is L by K3A is equal to 100 minus theta divided by R1 is L by 2L by K1A plus 100 minus theta by 2L into K2A. Now, why I have written L3? This and this L will cancel. Again, area also will cancel. K1, K2, K3 they have given. So theta into K3 135 will be equal to 100 minus theta by 2 into K1 plus K2. K1 plus K2 120 plus 60, 180. So theta into 135 is equal to 90 into 100 minus theta. So 135 plus 90 into theta is equal to 90 into 100. Mhm. 90 into 100 divided by 225. I'm getting 40. See?
Sir, I didn't multiply 90 to the both sides.
You didn't multiply. So 180 you did not do K1 plus K2. Silly mistake.
Yes.
What about you, Kanishka? Kanishka, are you there? Are you slept? So let me give you more questions to practice on this because this is an important concept. Okay, try to solve this question I'm giving. Try solving it.
Their option C K3 is equal to K1 K2 by K1 plus K2.
Yeah. It. C. Good. Very good. You solved it correctly. Acha. Now let me give you. It was asked in IIT JEE, then also in MPPT. Mm. Try solving this.
Sir, option C.
Let's see, wait, check. Correct way. Now you have understood actually how to solve series and parallel question. Now let me move on to the next concept. That's heat transfer by conduction we have read. Now we'll learn heat transfer by convection. I have already told you about convection now. What is convection? The heat transfer due to density difference. The examples also I have told you. In this one, in convection, means due to density difference, the movement of material takes place. Now here dq by dt is proportional to difference of temperature. Suppose there is this surface which is a temperature T1 and here is a temperature T2 and there is a movement. So the heat transferred between the convection is given proportional to T1 by T2, T1 minus T2 as we have seen in conduction. The only difference is this dq by dt, when we remove the constant of proportionality, it becomes HA into T1 minus T2, where A is the cross section area and H is the coefficient of convection. Don't worry, they won't ask you questions on this formula. And even if they ask, you can solve them. You solve them like you solve for the conduction problems. Only in this, the resistance I is same dq by dt. Resistance becomes RT as thermal resistance becomes 1 by HA. That only you have to remember. Delta V is again this T1 minus T2. I is dq by dt. For problem solving you can use. Okay. This is easy. Now comes the important one. That's radiation. Actually, the radiation part, before the radiation part, let me give you one more question. The radiation part I'll complete in the next class. Small only. Acha, Haripriya, do you know the anomalous expansion of water?
Yes, sir.
Hmm. And how it is useful? It is useful actually for the aquatic life. Now you know this one.
Yes, sir.
Hmm. Very important. Because of this only, this aquatic life is possible. Cold area. For Kanishka, let me tell you what is anomalous expansion of water. Water reaches the highest density. Means usually what happens when we raise the temperature from 0 to increasing the temperature, what happens? Temperature is raised, it absorbs the heat, molecules starts to move, it expands, and the density begin to decrease. That usually happen. But in the case of water, it does not happen. In the case of water, from 0 to 4 degrees Celsius, the density increases. And it becomes the maximum density at 4 degrees Celsius. And then after, if you raise temperature above 4 degrees Celsius, the density starts to decrease. But Haripriya, can you tell me what's the reason for this? Why the water has the density, maximum density at 4 degrees Celsius? Why not as in ice? Why does the density increase from 0 to 4 degrees Celsius?
So it's something related to the structure of the molecules in water.
Mhm. It's the bonding,
Like the H bonding.
hydrogen bonding. It's the hydrogen bonding. And hydrogen bonding, if you have learned in your chemistry, do you know what is hydrogen bonding?
Yes, sir. The weak attractive force between hydrogen and an electronegative atom.
There are only three elements which can form hydrogen bonding with hydrogen. What are those three elements?
There are no only two, like oxygen, fluorine, and nitrogen.
And then three, na? There are three. Oxygen, nitrogen, and fluorine, there are three, na?
Yeah, sir. I remember nitrogen now.
because they are very high electronegativity, anomalous behavior. That's why. And because of this, what happens actually, na, when it is present in ice form, it has crystal structure. When you raise the temperature, it loses that crystal structure and water is formed. But when water is formed, it due to hydrogen bonding, it begins to form hydrogen bond. Temperature is not that high to break the hydrogen bonds, and hydrogen bonds, so the density tends to increase up to 4 degrees Celsius. After 4 degrees Celsius, hydrogen bonding begins to weak, begins to break. Hydrogen bonds begin to break, and then when the bonds begin to break, the density keep on decreasing after 4 degrees Celsius. That's the reason. Take this question as homework. You will be able to solve, and then in the next class you'll start the radiation. Because if I start now, nothing will know. In 1 minute, nothing will complete. Okay, let's end it.
Bye.
Bye bye.